Today we're going to talk about lesson 7.1, which is about the angles of polygons. So both on the inside and the outside, or the interior and the exterior of polygons. But first, before we get started, I'd like you to do these 3 problems. So go ahead, pause this video while you do the review. So for the first one, the exterior angle x would be 120 degrees because each of the interior angles is 60 degrees since it's an equilateral triangle. And then those two form a linear pair, making x 120. On number 2, the value of x would be 70 degrees because they are alternate interior angles. And then on number 3, solving for the missing value of the inside of the triangle, that would be 61 degrees for that interior angle. And then again, like number 1, we have a linear pair, so subtracting 61 from 180, that exterior angle would be 119 degrees. Now normally, if we were in class, we would be doing an activity right now to discover how many degrees there are inside any given polygon. So most of you already know, and we've talked about this before, the interior angles of a triangle are 180 degrees. Now, for a quadrilateral, again, most of you probably have that memorized, the interior angle sum is 360. But to understand the reason why, if we were to divide this quadrilateral into 2 triangles, each triangle would have a sum of 180 degrees. Well, 180 and 180 gives us a total sum of 360. We can keep going with number of sides. We can keep adding them because I can always draw in triangles. So in this pentagon, I now have 3 triangles. So 180 degrees, 180 degrees, and 180 degrees. So if I add all 3 of those together, we get 540 degrees. Now you can see that the interior angle sum is always 180 times however many triangles there are. So in a quadrilateral there were 2, so we took 180 times 2 to get 360. In a pentagon there are 3 triangles, so we took 180 times 3. Now in a hexagon we would have another triangle, so we would take 180 times 4 for a hexagon because there would be 4 triangles. And we would get 720. Now, if, again, we were in class, I'd have you looking for a pattern, and hopefully you recognize a triangle has 3 sides. Well, there's 1 triangle. A quadrilateral has 4 sides. There are 2 triangles. A pentagon has 5 sides. There are 3 triangles. And a hexagon has 6 sides, and there are 4 triangles. So the number of triangles is always 2 less than how many sides there are. Let me say that again. The number of triangles is always 2 less than the number of sides there are. So then we can figure out how many triangles and take that times 180 to find our sum. So that's where the formula for the sum of interior angles of any polygon comes from. It is S, the sum, is equal to the number of sides, so I'm going to put n because we don't know how many sides, minus 2. Because that gives us the number of triangles. Well, once we have the number of triangles, we go ahead and we take that times 180 degrees. So if a shape had 12 sides, using this formula to figure out how many total degrees there are, we would do 12 minus 2 times 180. Well, 12 minus 2 is 10. 10 times 180 is 1,800. So a 10-sided shape, or a decagon, would have 1,800 degrees in it. We're also going to take a look at the exterior angles of a polygon. And when I do this in class, I always have students predict how many degrees do they think are on the exterior of a polygon. Sometimes I get it's the same as the inside. Sometimes I get that it's going to be more degrees than it is on the inside. Sometimes I get that it's going to be less. So I want you to just pause this and think, how do you think the degrees on the outside of a polygon relate to the degrees on the inside of a polygon? All right, so I've just sketched a few shapes here: triangle, quadrilateral, pentagon, and we're going to investigate the exterior angles of each of these shapes. Now, when I say exterior, that is if I were to extend the side of the shape, what is this exterior angle like you did in the review? Now, I chose to pick some pretty easy numbers to work with, but know that we could put any numbers in here and this same relationship's going to happen. So if I have an interior 45, this would create a linear pair. Therefore, the exterior angle would be 135 degrees. Extending my line up here so I can find that exterior angle, I would also have another 135 degree angle. And then lastly, if I were to extend my third side, since that interior angle is 90 degrees, the exterior angle would also be 90. Now, if I sum these three, 135 plus 135 plus 90, go ahead, do it, find the sum, we get 360 degrees. Now, 360 degrees is more than what's on the inside of a triangle because that's 180. So is it always going to be more? Let's keep going. If I draw in the exterior angles for this quadrilateral, 120, linear pair, 180 minus 120, this angle would be 60. Extending, this angle would be 120. Extending, this angle would be 60. And lastly, this would be 120. Now, if we add all four of those exterior angles up, 120, 60, plus 120 and 60, that totals 360 degrees. That's the same as what's on the inside of that quadrilateral. All right, we better keep going. So let's take a look at this last one. If I extend this angle here, we got a 40 degree exterior angle because 180 minus 40. Extend this one, that'd be 80 degrees. Got a nice 90, so this is going to be 90. 90 again, go with it. It's marked right. And then this last one's 120, so that's 60 degrees. Now, if you add all of those up, you'll see that they also add to a total of 360 degrees. So in sum, really, no matter what polygon it is, we could keep going if we wanted to. The sum is always going to be 360 degrees. For the exterior, it doesn't matter what shape it is of a polygon, the exterior angles will always be a total of 360 degrees. So this is just the theorem of those interior angles, that sum that we talked about. The sum is equal to the number of sides minus 2 times 180. So if you want to write that down, we're going to be using it a lot. Now, we're going to go ahead and move on to some examples. So I want you to pause the video and then you try and figure out the examples. And then unpause it and I'll have all of the answers up here ready to go. So in that first one, we're just using that sum formula. We got 8 sides, so subtracting 2 to get the number of triangles, and we take that times 180, resulting in 1080 degrees. Now make sure you do this first part first, or you use parentheses on your calculator, otherwise you will not get the right answer. Your calculator needs to know that it has to do that subtraction first. Number 2, very similar. The total would be 1620 degrees. Now number 3 is a little bit different because instead of asking for the sum, this time I'm asking for how many sides. So I'm going to put 900 here, I underlined it, in for the sum. So 900 is equal to n minus 2 times 180. Well, I need to know the number of sides, so I've got to solve for n. Need to solve for n here. So divide by 180 to both sides. Then I'm going over here. I have 5 equals n minus 2. Well, n's not isolated yet, so we got to add 2 to both sides and we get 7. Therefore, a shape with 900 degrees on the inside has 7 sides. All right, let's continue on with some more examples. Now, instead of asking for the whole sum or how many sides, you got to figure out the sum and then solve for the value of x. So I'm going to go ahead and walk through this first one. It is a quadrilateral, so 4 minus 2 is 2 times 180 would be 360. And maybe you have that memorized, that's fine. We can set up an equation. So I'm going to add 108 plus 121 plus 59. That's 288 plus that fourth angle x has to be 360 degrees. Now we got to do a little bit of algebra. Solving for the value of x, subtract 288 from both sides. X is 72. All right, now this next one says a convex polygon. That just means no sides cave in. We're going to talk about that a little bit more if you don't remember that back from chapter 1 or 2. But the sum of the interior angles is 1,440. Now, this is very similar to that number 3 we just did. Figure out how many sides it has. Go ahead and press pause. All right, so you can see I set up a similar equation. Now, the last step I didn't quite finish solving. We have n minus 2 is equal to 8, but we have to add 2 to both sides, so then we can tell that this shape has 10 sides, or it is a decagon. Okay, I want you to go ahead and try this last one. So the interior angles of a quadrilateral are x, 3x, 5x, and 7x. Solve for the value of x, and then find all of the measures. So go ahead, pause, and try this one out. All right, so if we add all four angles, x, 3x, 5x, and 7x, total, we would have 16x, and that's equal to 360 because it's a quadrilateral. So that's where I have this 16x equals 360. Dividing both sides by 16, the value of x is 22.5. Now, we have to actually answer the question. So the question is, what are the measures of the interior angles? So if I substitute 22.5 in, this first angle would be 22.5 degrees. If I substituted in the next angle, 3 times 22.5 would be 67.5 degrees. Substituting it in, that third angle, 5 times 22.5 would be 112.5 degrees. And then the last one, substituting it in, I would get 157.5 degrees. Now, 22.5, 67.5, 112.5, 157.5. If I add all of those together, I get 360. Therefore, I can check my work, and I know that I did it correct because that is the angle sum of a quadrilateral. All right, let's take a look at this next one. Now, I'm not sure if you have heard this word before, but if a polygon is regular, it means it has the same angles and the same sides. So all angle measures are the same, all side lengths are the same. So is this pentagon over here a regular pentagon? So let's take a look. We know that these three angles are all 90 degrees. We don't know those other two angles. So I'm going to set up an equation to solve to help me figure this out. So I'm actually really doing part B first. So 90 plus 90 plus 90 is 270 degrees. Plus, well, x and x, because those are marked to be congruent, so that's 2x, is equal to, now the sum of a pentagon, 5 sides minus 2 to get the number of triangles, times 180. The sum of a pentagon is 540 degrees, so I can use that in my equation now. Doing a little bit of algebra, subtracting 270 from both sides, I would get that 2x is equal to 270. Divide both sides by 2, x is equal to 135 degrees. So that answers B. The measure of angles C and E are both 135 degrees. Now, to answer question A, is it regular? Well, no, it's not regular because not all 5 angles are the same measure. 3 of them are 90, 2 are 135. So no, they are not all equivalent. All right, I want you to go ahead and do number 8 and 9. So pause the video and then I'm going to pull up the answers here in a second. All right, on number 8, since those bottom two angles are equivalent, that's where I'm getting that 2x from, and then adding the other 3 together, 334. Now doing a little bit of algebra, I solved and found that the value of x was 103. So both angle S and angle T are 103 degrees. Now number 9 says sketch a pentagon that is equilateral, so the sides must be equal, but the angles are not. I actually kind of used the pentagon that we had on the last slide, where these bottom angles were 90, and that top angle was 90, but then those other two are obtuse angles, so therefore it would not be equilateral. All right, we've already talked about this theorem, but if you want to write it down just as a reminder, all of the angles on the outside of a polygon will sum to 360. No matter what shape it is, no matter how many sides it is, if it is a polygon, the exterior angles, when they're extended, will add up to 360 degrees. So now we're going to go ahead and try some examples. So this is very similar to those for the interior angles. a lot of algebra that we're using. So go ahead, pause the video, and try to solve these two examples. All right, for that first one, I'm sure we got that. Setting up our algebraic equation, we would solve the value of x is 68. Now, it didn't ask, but we could plug it back in to find that exterior angle if we wanted to. Now, number 11, this is a little bit different, and I might have gotten you on this one. It says find the measure of each, and I circled it. If you got 1800 or 1800 degrees, you were close. But 1800 is the total of all of the angles. Now, to find each of the angle, think about it. What would I have to do if 1800 is the total? Well, there are 12 angles on the inside here, 12 of them. So I would take 1800, my total, and divide it by 12. Well, 1800 divided by 12 means each of those angles, and we can kind of see that in this trampoline, is 150 degrees. They're all obtuse angles. Now, the last one, maybe you're thinking, well, an exterior angle forms a straight line. That's 180. 180 minus 150 is 30 degrees. Sure, you could think of it that way. Or the other way to think about it is, well, the sum of the exterior angles is 360. Well, I would have 12 exterior angles. 360 divided by 12, you still get 30 degrees. It doesn't matter which way you think about it, so do whichever one makes the most sense to you. All right, we've got two more examples, so go ahead, pause the video, and I want you to work through these on your own. All right, if you add up those 5 angles and you take them away from 360, because that's the total for an exterior, you would result with 77 degrees for that 6th angle. Now, number 13 made you think a little bit, and that's exactly what I was talking about on the last slide. It was talking about if the interior and exterior form a linear pair, you can use the fact that they add up to 180 degrees to figure that out. We're going to go ahead and stop there for today. I want you to do homework 7.1 out of your binders. So again, do homework 7.1 out of your binders, and I'll get you those answers.